Hello students, welcome to Screencast number 4. You guys know how this works. I present to you a real-world problem, help you to solve it, then I present one of your own for you to solve, and you give me your response. Anyways, let's get right into it. This one's about freight trains. You guys know what those are. Freight trains are these things. You've seen them. They've stopped your car when you've been a passenger in it, and you've had to wait and wait and wait and wait and wait as the freight train goes by, goes by, goes by. Car after car. We've all been in that situation. Anyways, this one has nothing to do with waiting. This one has to do with doing. Here goes. A freight train with 80 cars transports coal and iron ore. Each car carries either 100 tons of coal or 90 tons of iron ore. That's good to know. So we have two types of cars. One carrying coal, another carrying iron ore. We have parts A and B. Let's tackle A first. Let C, we're going to use the variable C, represent the number of cars carrying coal. Write and simplify an expression. That is an expression. Remember, no equal sign. In terms of C, for the total weight of the freight transported by the train. Now, when it says in terms of C, that just means make an expression and let C be a variable within it, as you'll see in just a moment. Sounds fancy, it's really not. That just means create an expression that has C as a variable. And we have to create this expression so that the C, in terms of C, so that the total weight of the freight train is transported by, the total weight of the freight train transported by the train is represented. And then for part B, then we actually put in a number for C. Suppose 28 of the train's cars carry coal. What's the total weight of all the freight? So we're going to do parts A and B right here, right now. So let's look at it. What I've done here is I've sort of created an equation, yes, because it has an equal sign, but we're going to use it so that we can set up our expression. We know that total weight, because there's only two types of cars, we know total weight is going to be the coal car's weight plus all the iron ore car's weight. There's probably going to be a lot more coal cars and iron ore cars than just like 1 plus 1, of course. So we have to figure that out. Only using the information they gave us. Well, we got this. Notice that it said right there in part A, let C represent the number of cars carrying coal. All right, so C is equal to the number of cars carrying coal. So we've established that right there. So let's think about this. Let's take this in pieces. Let's start with the coal car's weight. A coal car carries 100 tons of coal. And since we're talking about weight, we know that one coal car is carrying 100 tons of coal. In other words, it's 100 tons. Which means if one coal car is carrying 100 tons, then two coal cars are carrying 200 tons. And three coal cars are carrying 300 tons. And four coal cars are carrying, okay, you get the idea. Basically, we're taking 100 and multiplying it by the number of coal cars. However, we don't know the number of coal cars. We call that C. It's our variable. But that does give us enough information to go on. Let's think about this again. If one coal car carries 100 tons of coal, then that's 100 times 1. Two coal cars would be 100 times 2. Three coal cars would be 100 times 3. Four coal cars would be 100 times 4. Five coal cars would be 100 times 5, and so on and so on and so on. C coal cars, remember C is the unknown number of cars carrying coal. C coal cars would be 100 times C. And that's where we start. The coal car weight is going to be represented by 100 multiplied by C. Like we said, if C were 1, that's 100 times 1. If C were 2, that's 100 times 2. If C were 3, that's 100 times 3. But we don't know what C is. So it's 100 times C. Now we're ready to establish the iron ore car weight, which is going to take a little bit more of explanation. Here's the thing though. You would think we need two variables, one to represent coal and one to represent iron ore, but we really don't, because we need to first write this in terms of C and C only. It did not say write it in terms of C and some other variable. All right, so let's think about this. There are 80 cars. In total, on this freight train. It says it right there, 80 cars in total. And we know C number of cars are carrying coal. So let's take a real world example here. Let's say there are, and we don't know this for certain, but let's say there's 20 cars carrying coal, and there's 80 cars in total. The iron ore cars would be 80 minus 20. In other words, there would be 60. All right, well, let's say there are 10 coal cars. Knowing that there's 80 cars in total and there's 10 coal cars, we know the iron ore cars must be 70. In other words, 80 minus 10. Using this information, what we also know is that C represents the number of cars carrying coal. We don't know that specific number, we just know the variable C that represents that unknown number. Which means we take the total number of cars, which is 80, and subtract from that, as we just did, the number of cars carrying coal, in this case C, and that represents the number of iron ore cars. Let's put that in parentheses. Because did you notice how over here we also had to multiply our variable C by 100? Because the coal cars are 100 tons each, but the iron ore cars are 90 tons each. So while this represents the number of iron ore cars, and each of those is 90 tons, then we also must multiply this by 90. So what we have here is the number of coal cars, C, multiplied by 100, plus, right? The plus sign carries down, the number of iron ore cars times 90. And now we're ready to simplify. Before we do that, though, let's kind of shove things together. 100 times C, I think it's much better to write that as 100C. And 80 minus C times 90, that might be a little misleading because we can simply write that as the 90 like right up next to that parentheses, can't we? And in doing so, that's going to help us significantly because now what we need to do is simplify. All right, well, we know how to simplify. Look at the 100C, nothing can really be done there, but feast our eyes on that 90. Ah, yeah, distribute that. All right, now keep in mind we're distributing it to this 80 and this minus C, which you are more than welcome to think of it as negative C. Heck, you're more than welcome to think of it as negative 1C. Remember that phantom 1 might help us greatly. So let's see here. 100C does not change. Plus 90 times 80. Well, 9 times 8 is 72. So 90 times 80 is 7,200, otherwise known as 7,200. And 90 times negative 1C, well, 90 times negative 1 is negative 90, but 90 times negative 1C is negative 90C. Now we're in a really good spot to put all of this together. 100C, negative 90C, those are like terms. It really helps if we box our terms. And if we box our terms, we clearly see that 100C is positive, 7,200 is also positive, but 90C is negative. We clearly see that 100C and negative 90C are in fact like terms. So 100C minus 90C is, of course, 10C. And then the 7,200, which does not have a like term, simply brings itself down. And voila, we are done with part A. 10C plus 7,200, which means we are ready for part B. Part B, as you can see, says, suppose 28 of the train's cars carry coal. What is the total weight of all the freight? Well, in part A, we just represented the total weight of the freight with an expression. So we're going to use that expression, the simplified version, because it's going to make it easier for us. And if it says, suppose 28 of the train's cars carry coal, we know that what was once C, an unknown, the number of cars carrying coal, is now 28, because 28 of the train's cars carry coal. So we can now safely say that C is equal to 28, which means we take this 28, and wherever we see a C, we replace it with 28. And remember, 10C is 10 times C. So make sure you are somehow indicating that you are taking 10 and multiplying it by 28. I like to use parentheses. And now we use proper order of operations because variables are gone, so therefore we must use proper order of operations, which states multiplication before addition. So the first thing we have to do is 10 times 28, 280. And then of course we add to that 7,200. And 280 plus 7,200, that's right, 7,480. Now what's the unit? Oh yeah, we're talking about freight trains. And we're talking about tons of coal and tons of iron ore. So if you have 28 coal trains in total, that whole freight train is 7,480 tons. Voila. Nice job, everyone. Now I want you to solve something very similar, but a different situation. Here's what you're going to solve. You have a problem that looks like this. While training for soccer, you work out each day after school. During your workout, you lift weights and play soccer for a total of 75 minutes. You burn 7 calories per minute when playing soccer and 3 calories per minute when lifting weights. Here's part A. Let T be the time in minutes you play soccer. Write and simplify an expression in terms of T for the total calories you burn during your workout. Again, all that means is create an expression and only have the variable T in it. You're writing everything in terms of T. That's what it means when they say in terms of T. And then for part B, find the total number of calories burned if you play soccer for 55 minutes. So first you have to do part A, create that expression. Then you have to do part B, in which you take 55 and plug it into the expression wherever you used your variable T. And then you'll have your answer. Now, let me give you a little hint here, okay? Remember how before we kind of set up sort of a general word equation that kind of helped us? Same thing here. Reading this again, it says, while training for soccer, you work out each day after school. During your workout, you lift weights and you play soccer for a total of 75 minutes. You burn 7 calories per minute when playing soccer, 3 calories per minute when lifting weights. We want to write and simplify an expression in terms of T for the total calories you burn during your entire workout. So your total calories, which I will abbreviate with CAL, which represents calories, is going to be the calories from soccer plus the calories from lifting weights. So create an expression just like we did before that represents how many calories you burn from soccer, and add to that how many calories you burn lifting weights. And also they tell you that T is the time in minutes you play soccer. So the time in soccer. All right, from there I think you should be able to take over. This is due next class. You are more than welcome to contact me. If you need help, be more than happy to. You know how to respond to this. You can do any of the means that you've been using in the past or any other creative one that you can think of. Have a good time.